All right, welcome back, everybody. This is the Virtual Residency Workshop 2026. It's Tuesday, June 23rd, and this is the fourth and final session of the day. So our session is researcher perspectives. What do researchers need from cyber infrastructure facilitators? And our was to have been moderator unfortunately had a family emergency and was not able to be here with us. So I've substituted in on his behalf. And so I think let's go around and do introductions. So everybody maybe take a minute and tell us your name and your institution. We'll start with Keith Chang.
Hi, Keith Chang. I'm at Penn State College of Medicine. Um, I am the director of this new Center for Computational Phenomics, been in the Department of Pathology with affiliation with biochemistry, and now uh, molecular precision medicine. My interest is in my expertise is in pathology. I have a residency in anatomic pathology, and I combine that with my background in biochemistry and now genetics and now phenomics, which is the systematic study of phenotype um, across, say, all genes or chemicals.
Thank you. And Jedediah Lindberg.
Yeah, so hello, my name's Jedediah. I'm with the University of Central Oklahoma. My field of expertise is statistics, and my research of interest is mainly ecological data, particularly doing spatiotemporal models of different phenomena out in the world. I've also worked in reinforcement learning and some machine learning, those kind of aspects.
Thank you. And Mike Dinneman.
Hi, everyone. I'm Mike Dinneman. I'm at Old Dominion University down in Southeast Virginia. I'm an oceanographer and I mostly do ocean circulation modeling. So I run these Navier-Stokes geophysical fluid dynamics codes. And I've worked in regional oceans all around the world, but these days it's mostly Antarctic stuff. So do a lot of ocean ice sheet interaction and also some ocean ecosystem interaction type stuff.
Thank you. And Stefan Robila.
Hi, I realize that there's a competition between this activity by Henry Neiman and activity by Harry Keene in Boston, but I appreciate you being online today. So I'm Stefan Robila. I'm from Montclair State University. This is a state institution in New Jersey, 13 miles of New York City. I'm a professor of computer science. However, my background is in remote sensing and especially hyperspectral imaging, and that got started during my graduate studies. And that's also where I started connecting with high performance computing. Since then, I looked at the various other things, including cybersecurity, computer science education, and in the last decade also energy consumption, especially for data centers.
Thank you, Stefan. And Stan Svoyanovsky.
Yeah, correct. Hi, I'm Stan Swianowski from Missouri Western State University here in St. Joseph, Missouri. So welcome from up in the prairie. Um, I'm from Department of Chemistry, of course, teaching chemistry and biochemistry courses, and I'm focusing my research on the AI neural network applications in biomedical research. So we are doing the analogs for the anti-cancer drugs using the AI from this part into the fine identification of active oligonucleotide sequences using the artificial neural networks. So that's the current status.
All right. Thank you, Stan.
Mhm.
So we've got a bunch of questions prepared, but we can abandon them at any time if you all want to go down a different path. And of course, in response to audience questions, either in the chat or by voice. But we'll just go ahead and get started with one of our prepared questions. To what extent do you see your research dependent on research computing and data services today? And how do you see that evolving in the future? What about your research community more broadly? And I'll throw that to Stefan first.
Oh, thank you, Henry. So I mentioned that I started my graduate studies working with the faculty at Syracuse University, and that was the moment when I was exposed to shared memory, parallel computing. And at that point, the only way you would be able to process large images, such as hyperspectral images that even 20 years ago they were 200 megs or higher, was to really, if you wanted to do it efficiently, you had to use a parallel environment. So my career started with the need for research computing. And after a while, given the growth in performance in individual desktops and machines, I thought that I don't necessarily need clusters because usually my type of data was focused on single stream instrument based imaging. Today, however, you see a different thing. Today, you have a large amount of data that is coming from multiple sources. You have satellites, you have airplanes, especially again, I'm still thinking of the type of data I'm working with, and you also have desktop-based instruments. So now there are new problems that you can solve, including mapping various global properties, including trying to extract information from multiple sources. So now you are back, not now, but in the last decade, we have been back to the question of how can we process data at a very large scale, how we can build workflows that will allow us to ingest all data from commercial and academic and not-for-profit sources and then produce intelligent results. So today I cannot function without research computing, without high performance computing. And usually I cannot function without research computing even within my institution. You are muted.
Can you talk a little bit about the role that research computing facilitators play in that, both for yourself and more broadly within your discipline?
Yeah, so I will call you up, Henry. And when you asked me if I would be interested to participate, you also asked me to give you my experience and the background of my institution. And one of the questions that you had for me was, do you have research facilitation at your institution? And my answer was no. We do have a couple of system administrators that kind of play dual roles, well, multiple roles. They are supposed to help academic facilities within the college. So that includes even presentation desktops and everything else, and individual faculty laptops. But also they play the role of sysadmin. And they also play the role of facilitators when one of us gets stuck. So without them, we would not be able to have anything. I wish we would be able to also have the real research facilitators, the one that can focus on research computing and not mix teaching responsibilities with production environment responsibilities and other things. I think there is a hope at my institution, but I don't see it happening anytime soon. I think that without my sysadmin, because I have to say he's still a sysadmin, our cluster would not be standing today, and none of the clusters that I was involved in the last 15 years would have been even purchased if we would not have the support. So I've seen colleagues at my institution that have tried to do this by themselves. And while eventually the cluster or the instrument was functional, it continued to be plagued with issues in maintenance, in access, and then eventually died much earlier than anything else that was supported by a well-thought research facilitator or sysadmin at least.
Thanks. Mike, throwing it to you.
Well, as far as how it's dependent, the stuff I do is totally dependent on research computing. And I've been running parallel codes for, gosh, I don't know, 25, 30 years now. But we can do different problems now because of the advance in computations. Just, I run a Navier-Stokes code. It's geophysical fluid dynamics, and it's on a gridded field. And for example, there's an ice shelf that I want to see. The ice shelf is a floating part of the Antarctic ice sheet. And so the physical domain of this is about the size of Texas. But the physics is such that you need individual grid resolution on the order of a kilometer, or there's some physics you just can't resolve. And so that's a heck of a lot of grid cells. And you can't do it without research computing. It's a question I wouldn't be able to answer. I'd have to do something else.
And
Sorry, go ahead.
I was just going to say, do you find that your local research computing experts are valuable in getting that research going and getting it and keeping it productive?
Totally. I mean, we've got a pretty nice shared university system, and there's no way I could do something myself with this. And not only that, so, I use this open source code. And so, there's you get what you get in terms of help for things. So there's stuff when I just can't get it to run on the system, say there's a new compiler or there's a new version of the code, I'd be totally sunk without the facilitators we have who can help me get this stuff going. And then recently we just added access to a Google Cloud system. And I wouldn't have the first clue on how to get my project up and going. But with the research facilitator, it was, they went to a lot of effort to get a system similar to how we have it now. But for me, it was easy peasy to get my model up and running. Like it took me an hour to get it up and running because, I would have floundered for weeks.
Do you think that's generally true more broadly across your discipline?
Um, it varies. Like some people will use stuff, depending on the problem, they might actually use national level infrastructure, in which case there's a huge support system. But there's other people I know, like we had grad students here who she went to a different university and she had access to a cluster, but they said, here's what the compilers are, you're on your own. And she floundered for a while because she didn't have that kind of help. And it was a real pain for her.
Stan, how about you? And Stan, if you're
Okay,
talking,
yeah,
there we go.
I hear you. In our research, I'm not really any kind of the computer geek or specialist. I am just a friendly user, so I can get as much help as I can get. I always appreciate. We are focusing on the machine learning models, usually for the undergraduate students, which is really not so high technology. Um, it's really relatively simple principle, but it's part of the applied learning for the students because once they are involved in this, these projects kind of absorb them to do more and more. So when we use the MATLAB, we usually have one computer which is dedicated for the research because we cannot work any of these uh, AI prediction without a computer. However, we expand the research, and right now we are doing the genetic structures and prediction of the different oligonucleotides and so on. We are working with the sequences ACGT. However, the computer cannot understand any ACGT, so we have to transfer this into some kind of numerical expression. And we started with the numbers, but once you put there the numbers, you already add some kind of statistical bias. So what we are doing right now, we are expanding this into some kind of uh, binomial distribution when there is really no bias. Then the project has really exceptionally big, and it is beyond our capability actually just to use the regular computer for this because the model is overloaded. So that's why I approach our research facilitator, and we have the access to the supercomputer. And I hope that it will help us to continue with the next step on this research with some kind of, binomial or some other distribution of the data and continue with the undergraduate students there. We do have the research facilitator here, which is extremely helpful because this is the person from our department too. So we are on the colleagues on almost daily basis. So he listens a lot what we need, and he's so far very helpful. I cannot do it without additional help because simply it's beyond my knowledge. I teach chemistry and biochemistry. So what do I need know about the supercomputers? Almost anything, but the computer goes because it's not just interpersonal, but it is interdisciplinary research.
Yeah, that makes a lot of sense. And do you think that's true more broadly across your discipline?
It is, but as I mentioned, I teach the biochemistry, but we are doing right now project on the genomic sequence. 2 years ago, we did anti-cancer drugs. We focus on the Taxol, not to enhance the efficacy of the or cancer efficacy of the drugs. We don't have equipment for this, but maybe reduce some kind of adverse effects or something. So it was really a very nice project, but again, it's intensive, it's computational intensive, and we need more power. So our hope here is that with some kind of access of the supercomputer and this format, we will be able to continue this way, which is really very exciting, especially for undergraduate students, and very helpful. If they have publication or two, then it's much better for them.
Thanks. Keith, your thoughts?
Well, I've had a very interesting long history. When I started, there were only mainframes. I did basic and Fortran programming, which made me decide not to pursue that stuff. And then later on, I began to use mainframes to do bioinformatic investigations when I was in grad and postdoc. And now I have, let's stretch it. Once I got exposed to the idea of genetic screens and reverse genetic screens, which are done by saying, for a series of genes, what is the function of each gene by making mutants in each one, and then asking what is the resulting phenotype. So you learn about a gene's function by knocking it out in a model organism. The equivalent in a car is to I don't know what this part does, pull it out, see what happens. So in genetics, you knock out the function of a gene by breaking it, by using CRISPR these days. And you can do magic things like there's a technology called MIC drop for zebrafish, where you can inject one CRISPR construct per embryo, per drop, one embryo, one drop. And so we can have the idea of, well, we can make a mutant for every single gene. Isn't that nice? But then how do we phenotype it? What cell type is affected? You don't know ahead of time. So we've designed a method using computing. If it weren't for computing, it'd be totally impossible. We can image every cell and characterize every cell in a whole organism now using micro-CT. Micro-CT is computational. You take a bunch of rotational projections, and one row at a time, you can compute the 3D structure of that whole volume. So we just published a paper in eLife. It's, I think, 2.6 terabytes, 1 centimeter diameter, and we have 300 organs segmented manually, someday automatically, and we're able to use the computer to trace convoluted structures through the whole thing by putting dots in the middle, making linear, tracing the center, and then generating perpendicular planes, and then using segment anything to label the whole thing across the whole length of the structure, and then placing that in the original volume. So these are magical things that can happen. If you want to look that up, just eLife and Octopus and Cheng, for example, that'll be in there. And we recently also submitted a paper looking at prostate cancer. Again, impossible computational. We're actually getting resolution allows you to do histopathology in 3D. So we can actually make pretend hematoxin stained sections anywhere, any direction you want in the whole sample. And the idea is we're going to someday be able to characterize the individual patterns that correspond to human cancer and have more precise treatment. So these are dreams come true because of computing. If I asked these same questions 10, 20 years ago, forget about it. Can't possibly do it. Now I was just last week at Argonne National Lab, where imaged a whole volume, in 6 minutes, and reconstruct it using the Aurora supercomputer, I think, and get back the 3D structure of this thing. And we're using another web-based tool from Google, NeuralGlancer. If you haven't heard of it, it's really fun because you can look at 3 planes of section of the same organism and a 3D rendering with your segmentations if you generated them, all on the web. This is nuts. So then finally, I am using AI a lot, okay, in my work. How? Well, I have stupid questions. What does this term mean? So it answers those. But also, I have this idea. If I wanted to do this computational phenomics thing, which is what we're trying to do, what should it look like? What should it look like to the administrators? What should it look like for this funding agency? Um, and how can you please look at the literature to see what's known already about these things? And it helped me a lot. And when I iterate back and forth, you have to correct all the hallucinations. If you're a content expert, you can correct the hallucinations. That's key. You have to know something. That's powerful use of AI. And a colleague of mine who um, also does this, and I use Perplexity in my case. I have to pay for tokens. Um, Actually said it increases productivity by tenfold of his lab. So I am increasing my productivity. I'm not quite tenfold yet, but I need to get there, and I see it's possible. So this is the exciting part of the new world that's in contrast to the depressing part of the new world, which is, oh, I might lose my job. I might, but there's, if you focus on what's possible, then instead of worrying about what's happening to the horses, you can actually figure out what you can do with cars or with wheels. There's a lot of bad stuff. Anything can be bad if you use it wrong. If we focus on what you can do that's good for people, I'm focusing on what can I do with computers. I don't care where they are, and programmers who know how to use them. And what can I, with AI coming online now, what can I do now with the existing tools of the world with my interests and what questions I want to answer? So anybody can do that. All the students can do that. What am I interested in? What can I, what am I, what can I nerd out about that would be fun, and then do it? That's kind of my attitude now. I'm trying to maintain a good attitude. Attitude being about 90% of success, I think.
That sounds really great. So I'll keep throwing back the same question that triggered all of this, which is in there, and it sounds like you have a lot of computing experience in the context of your research, and background, and understanding of computing. Um, and I guess my question is, at your call it expert level, um, what value are you finding from the research computing team, and particularly the facilitators, the folks whose role is to help you use the research computing resources, whether at your institution or nationally or in a commercial cloud, wherever that may be?
I'll answer it in two ways, the good and the bad, because you have to balance everything, right? So I have also figured out how not to use computers. So if you go to an AI person, a student, say some recent graduate, they know about whatever AI they learned at their time, at the time, whatever the popular new AI tool was, and they may say, "Oh, I know that one tool, and I will apply it to your work." Well, what if it isn't applicable? So I had a whole project go down the tubes for a while for a graduate student because I took this suggestion, very kind suggestion of my my computing group. Say, we have a person who can help your student with this project. And it turned out to be a disaster because he didn't, what you're supposed to do is systems thinking and say, okay, I have this problem. What are all the possible ways to solve this problem? Let's say it's AI. What are all the AI tools? And then which one of them is best? That's systems thinking. Just sort of, I have this hammer in my toolbox. What can I do with this hammer? Well, there are some other tools that exist that you maybe should use the wrench. And if you don't use the wrench, you may be in big trouble. So this is the same thing that's going on with AI now. You can't just throw AI at anything and expect it to work. And in fact, a majority of the AI people I worked with at first, they said, well, you're not a computer expert. You don't know anything. You're just a biologist. Well, it turns out being a biologist, you know what the question is to ask. And if you don't know what the question is and you've never talked to the biologists, you get nothing useful out of it. Nothing. So there were several projects that completely failed because there was no interaction between the computer scientist and the biologist. So you have to have a native interest. So I decided this. So for those of you who want to learn about AI, this is what you do first. Find something you're interested in and study that deeply. And then ask, what can I do to answer that question? And it'll include AI, but you can't be just one kind of AI and you just throw it at it, expect success. It's not happening. You have to have content expertise to judge when you're hallucinating and judge whether you're doing something useful. And then you talk to your computer scientist, and you should be both. You should be interested in something and some expertise in computers. You don't have to know how to program anymore, maybe. Let the computer scientists decide that. But I know when something that's produced by the AI is nonsense, and a lot of it is. And I even yelled at Perplexity for spending $200 of my money and giving me nothing back one weekend. Spent a whole weekend, got nothing. But other stuff, incredible. So it has to be appropriate. So this is a range of results, and this could be, at a national level. I'm applying for grants. That I just applied for a Genesis grant from Department of Energy. I'm sorry, my answer is so long. And it's all AI. Like, well, I'm not an AI expert, but I can say I can work with AI and decide what's nonsense and work with the AI. So that unit of data plus person who knows how to interpret it is critical, and that's what I proposed.
Thanks. And Jedediah.
So for my research, I think you could probably do this without research computing if you didn't want to get to the depth of an answer that I'm actually interested in. You could probably do this on your own computer and maybe run the model twice and come up with some conclusions. But using a supercomputer, using a cluster, the depth of an answer we can get to. So if you're doing a spatiotemporal model, you're actually looking at the covariant structures of the things both through space and through time, which is quite usually what I do is controlled burns, working with the U.S. Forest Service. And so there's a grid and they're seeing how the fire burns. And I think it's actually brilliant. Like, it's something that we could only do recently because computers could keep up with it now. But we use a hierarchical model. So you're using two distributions, and then you have a posterior distribution, but it's not conjugate. So you can't theoretically work out what it should be. No problem. Okay, well, we'll sample. So then every time you're doing this, you're going to sample maybe 10,000, make sure the sample's large enough, everything kicks in. Okay, I know what the distribution looks like. I know what the covariant structure is. Now I move on to the next location. And you have tens of thousands of these locations. So if I want to run this model with any kind of analysis that I'd be satisfied with, where it's, well, I'm going to run it once, I'm going to put in all the wrong parameters, I'm going to need to change all the hyperparameters, I'm going to need to run it many, many, many times. And I need things to get to their consistency. I need the asymptotic behavior to happen. So when I use these supercomputers here at UCO, that's mainly what I'm doing, something my computer could almost estimate towards, but it couldn't actually reach the asymptotic behavior where I'm satisfied that I've got the power I wanted, the result is correct, this is what's happening. And this might be blasphemy to any other statistician, so if anyone's on the call. But I do appreciate being able to reach asymptotically with simulation what theoretically should be happening. That's really good validation for me. I appreciate that. I'm glad to go into the theory of it and look at it, but I really love being able to go, oh, the simulation's contradicting what my theory said. I better check my theory. Like, there's something off here. So though in my particular discipline, you could answer questions, I'd almost say in more of a surface level, using your own computer without using research computing. Once you have this tool, you can go so deep into the analysis. You can answer questions that we've had the data now for decades. We've just never been able to analyze it this deeply. And I think that's where the really interesting applications of statistics are going now, actually deeply analyzing large data sets.
And who do you go to when you get stuck trying to get the cluster supercomputer to do what you need, but you hit a speed bump?
Which happens frequently. So we have a professor here in the department. His name is Brad. He's amazing. It's not his full-time position to help with the cluster. It's something he's taken on for himself because I think if he didn't do it, we wouldn't have it. So I'm extremely grateful to him. And some Friday mornings, I take up his entire morning, which is really fun. We're friends, so it's not all work. But I definitely take up a lot of his time. And it's interesting, some of the things he struggles with. He's a much better coder than me in general. But if we were coding in R, which is my programming language of interest, it's interesting for me to see him trying to apply that to the cluster and going, I'm not sure this or this or this. And I'm like, oh, do this in R. If it's in R, do this. But then if he's talking Python or Java or anything else, I'm like, that's all you. But he's the one I would always go to. And it's one of the questions on here. Definitely, I think it would help to have someone who their job is research facilitator. They don't have any other teaching responsibilities or responsibilities at the school. They could focus on it 100%. That is not to diminish what Brad does. He's fantastic. And I hope he continues to take on both roles and wear both hats because we need him. But it'd be great to have someone come in and that could be their full-time position.
Yeah, that makes a lot of sense. All right, let's tackle another question. And I think I'm going to jump ahead a little bit, but thinking about research computing staff, and so this includes facilitators, but goes beyond facilitators. Which is more important to you, disciplinary expertise or research computing expertise? And why is that more important? Is it more important that they understand your research, or is it more important that they understand research computing and why? And I'll throw this one to Mike to start us.
Well, in my case, the more important one is research computing expertise because I'm, so in theory, the expert of the discipline. I mean, like I've used a bunch of different models and their open source code, and I've even contributed some of the code to it. So I know the model. What I don't know is, say, latest compilers or, what's the best way to get netcdf to efficiently write stuff in parallel. What aspects of the compiler do I need to do that? So for me, it's definitely the research computing expertise because that's not what I know. I'm not um, I don't do that. I mean, I use it, but they know way more of it than I do, and they know the specifics of their system. So even if I knew it on, say, a NASA system that I was a grad student at, I don't, I come to ODU, I don't know this system. They know it way better than I do.
Thank you. And I'm watching Jedediah nodding vigorously as you're talking, so I'm going to throw it to Jedediah next.
Yes, I highly agree with that. That's the expertise I want because in my research, if there's something that's a snag within my coding or something that I'm doing, that's kind of on me to figure out and fix. But there's things within the research computing expertise, I have no idea how to get that working. And Brad's fantastic at that. That's one of the things where I go like, I know how this package works in R, and I understand why it's working on my computer this way, but I can't get it into the cluster. I don't understand why they're not talking together. And so I understand everything I need it to do, but it's his expertise that goes, I know how to get this into here so you can actually work with it kind of in this remote desktop setting and it can do what you need there. And that expertise is really beyond me. I could do it. It just takes so much of my time and I'd rather just focus on what I'm doing. So certainly I completely agree with Mike. The expertise I want from them is the research computing and it's up to me to kind of help with my expertise if there's any kind of snag on that end.
Thank you, Jedediah. And Keith, I've been watching your thinking really hard face. So why don't we throw it to you next?
Yeah, so it's I have a conditional answer. So research computing, but what matters the most is whether the person who's in the position is interested in helping you and then has the energy and intelligence to go look if they don't know and to maybe do the perplexity search if they need to, so what they need to solve the problem, what other people who you address the same kind of problem, what kind of classes of tools, either old or coming up, might be most applicable to solve your research problem. So to me, the fun of science comes from working with people who actually want to help. I'm a little, worried about people who decide to limit the scope of what they know, limit themselves to the scope of what they know rather than asking, being question oriented. How do we address this problem? It's a orientation towards research. How do we answer this question? What's the ideal way to answer the question? And maybe they'll even have an idea of maybe you shouldn't use this approach, you should use another one. That's something a researcher would very much welcome. If I'm doing things wrong, I'd rather they tell me than the reviewer tell me when it's all done, or the grant reviewer, so you don't get your grant. I mean, you got to know whether you're doing things right or wrong. I'm interested in answering questions the right way. So,
Yeah, I think that that's a very helpful point and kind of indicates the importance and the value. And I'm going to self-plug on this, I suppose, the importance and value of getting training and experience across a broad variety of disciplines for a research computing facilitator, so that they have a general sense of the field, even if they may not know all of the particulars of that field. And I think a lot of us have seen that and experienced that in our own careers. Stan, your thoughts?
Yeah, I definitely agree with all of the people who talk about it. Um, our projects are already multidisciplinary. Uh, I'm in the chemistry department, but we are doing predicting on some kind of oligonucleotide sequences. I don't teach genetics, but the project already is multidisciplinary. So I really prefer facilitator who is more focused on my research, and we can talk, I can explain and all of this instead of doing simply for chemistry or biology, because actually most of them is in between. And in my project and my experience, we have more biology than chemistry in our project. So definitely agree with more research-oriented facilitators.
And Stefan, you want to weigh in?
Yeah, so what Keith said really resonated with me. I mentioned that at our institution, we don't have some staff that are identified as research facilitators, but our sysadmins play the role of research facilitators. And I have to agree. I mean, on one hand, they are often seen as IT support, and for me that is also very important because many of the needs that I have relate to a proper use of the resources. So often we complain about unavailability of access, unavailability of resources, or competition on resources. And especially when we work with students that may not be as experienced, they often do things that they necessarily do not get the best outcome. And having somebody with a very strong systems understanding, being able to look at the system utilization, being able to look at the dependencies among libraries and everything else is very helpful because before we complain that we don't have access to the resources, often the answer that we get is that, well, we just basically spawned too many processes and they're just hanging there since the last class. And that's very helpful for us in order to turn around and help our students. But what I also noticed, especially with my colleagues, with my sysadmin colleagues, is that they also have a much vaster experience because they don't work only with me in computer science. And of course, in computer science, I need more research support in terms of research computing supported than in domain because we know everything by definition. But I noticed that they're really interested and they have good experience with many, many other disciplines because they have been in the center of all, especially in our College of Science and Mathematics. And that's why what Keith said really resonated with me. They really want to be involved. They really want to be part of not just simply providing support. They want to be partners, not simply support staff. And I think that I'm not going to I'm not going to call myself up, but I will call some of my colleagues up, say that that should be also clear on our side as researchers that this is what we are looking for in partners, and we should understand that we have partner and not simply a support component to our work. And I think that's very important to us. So from my perspective, I do need support, especially for the research computing with more expertise, especially with optimal or best utilization. Especially, I'm thinking in terms of people that worked as campus champions to facilitate access to other resources beyond campus, and tell us, especially, people complain they don't have access to GPUs all the time. But this is not simply a source of information or source of IT support. This is also a partnership because I would not have been able to even design the cluster that we currently have without working directly, not their support. They work directly. We work directly to build it and spec it, and then still surviving a decade later.
Well, so this leads beautifully into the next question I wanted to ask. So, Stefan, you're going to lead us off on this. And I think I already know your answer, but I'll let you start us. What relationship do you want with your institution's research computing organization? And in particular, should it be integrated into your work or kept at arm's length?
Okay, I think yeah, right. I think I kind of gave the answer to this. I think that from my perspective, and I would say it's not necessarily shared by all my colleagues, I think it should be integrated in the work. And I think that's the expectation on the other side. Because there's a different expectation in terms of how do I present my needs and how do I interact, and also how the responses are. I would say that I have observed myself and other colleagues within my institution how to interact with our sysadmins, and in some cases you could see that despite having similar projects, our experiences are vastly divergent. And I think that the key here was you really need to work with them as partners. I'm reminded that NSF has no problem, in fact, encourages research facilitators and research computing professionals to be part of teams, submitting proposals, leading proposals, participating in all activities. And I think that should be, in fact, pointed to in some cases to remind us that we are not faculty and staff and other things. I think that we are part together of the same projects.
Well, and I was noticing Keith nodding along as you were talking, so I'm going to throw it to Keith next to respond.
So it's really a interesting question that applies across a lot of different levels of computing. So there's the research computing, like work on this research project, but then there's the computing that affects every faculty member that's not research computing that impacts incredibly how much work we can get done and how much distraction we have. So there's this, I'm sorry, I don't know, I hope this is appropriate. There's this disease in large institution whereby they hire some, I don't even want to call them programmers. They install new software and they make this new requirement. They invent new rules. Here's a new regulation. Now you have to do this by yesterday or you're going to lose your salary or something, right? So, and then you click on the link and it doesn't work. So maybe they should have tested it. So this should never be allowed. So if you're a computer science trainer, you should be trained. That's part of your job, is to test what you're imposing on your colleagues, whether it's in a company or in an academic institution. I don't care where it is, because right now we're suffering from this overload of new software that is just draining us of being able to be productive. So that's a philosophical, sorry, maybe it's a side thing, but and I really appreciate one thing I do want to point out what Stefan said is working together with the research will yield the best results, because they'll say, oh, there's this problem. So for example, Ian Foster, I happen to have met him at University of Chicago, created Globus. It's a pretty important tool. I mean, I was just fighting a battle to get Globus in node down here where I work. So because we got big data we got to transfer around to collaborators. So yeah, I think that comes from researchers working with computer scientists, on projects. Problems come up and they can solve them. I mean, they should be involved in writing grants for infrastructure that's needed. If we had this infrastructure, this would work a lot better, right? So I really highly encourage working together and then working on the problems that come up that certainly the subject matter experts would have not a clue what to do.
Yeah, and you've actually touched on one of the issues that is kind of one of my, I don't know, bugbears, that the distinction between research computing on the one hand and enterprise IT on the other hand,
Mhm.
and they do both have an important relationship to the research mission of an institution, but they address it in different ways and are qualitatively approximately the opposite of one another. So I actually had a segment of a talk earlier yesterday on exactly that issue. So you've kind of hit on something I love talking about and won't shut up about. Okay, so I'm going to throw this one over to Jedediah now.
Yeah, I'd echo basically what's been said about this. To say, should they be integrated fully into your work or kept at an arm's length? To me, it depends. Like if we're talking research, for mine, I want them integrated into my work. I want research computing. I want to understand what it can do, what they can do with me, how we can work together. I want a good relationship with them. But there's others in my discipline who don't do that much computing for their research, for their theory, and they wouldn't need it. So I'd understand kind of in that regard. It depends on the specific faculty and what their research interests are. But in general, for like grant writing, for understanding the infrastructure, these things, absolutely, like they're the ones who should be involved because we don't have the expertise. I don't know how to help if they need something like that kind of for that structure.
Thank you. And Stan?
Yeah, I agree that, um, it all depends on very personal level. So, you know, I need their help, but on the other hand, I understand that they have a lot of other stuff to do. So it's me who wants to be integrated into their work. So I need to have the access, I need to have the explanation, and I need to come with our problems and see solution. Most of these people are focused on the computation part only, and they don't see maybe the biological aspects, which is important for us, or they don't see all of the steps. They are talking about the memories and all of the other stuff, which is not really important for us. So just giving you the example, these are two different type of people, two different societies. The computer related people and biology, they don't really drink beer together. So in the past, when we were teaching these classes, we just put the biology and computer science students into one room and create a team, and they found a way. So it is in some kind of bioinformatics way today, and I think that it's very good that we have here on the small institution opportunity to use the big supercomputer, which is actually not even installed in our institution. We just have the access to Columbia, Missouri, to the big one. But it's very good to build a personal relationship with these people there.
Thank you, Stan. And Mike, your thoughts?
So Stan, when you put the biologists and the computer scientists in the same room, did you make sure there was beer in that room?
Plenty of beer.
Awesome. For me, it definitely should be integrated. I mean, that's how it has to work. I have certain problems that, I'm thinking about a proposal and I'll reach out to them. It's like, hey, what do you have? Can we do this? What are your plans on getting future stuff? Um, because, I mean, I've had one proposal where we talked about using national level resources, but for the most part, we have a really nice system here. And I try and use that, and I want to know how it's going to develop. And so I need to talk to them beforehand. And here it's actually worked both ways. One of our clusters was partially funded by an NSF MRI grant. And very smartly, those people reached out to a bunch of researchers, not just ones who are currently using the computers that they had, but other researchers on campus who they thought might have computational needs and said, help us build a use case. What are things you want to do that you can't do right now that if we can get money from NSF, we can do that. So it's it's not, at least for a lot of people here, it's not an arm's length relationship. It's integrated because it's worked well both ways, I think.
Okay, so I'm gonna continue along this general direction because I'm finding this very interesting. Um, so suppose the institution said we have a modest pile of money. It's enough for either a big chunk of hardware or another member of the research computing team. How you want them to spend the money? And I'll start with Stan.
It's really very theoretical questions because there is no such a thing as extra money in the pile. There is no such a thing in our institution. However, it's at the same time it's hard question because we really need both. Okay, so if I really cannot make this decision. I am just the regular soldier here, regular teacher. I leave this decision to the upper echelon. But what we would prefer is actually a little piece of both. If there is the new software something, and I still use the archive, MATLAB or something, uh, which is right now not really the best way for the computation model. So we try to update it, and we are doing this in Python or something. So I would appreciate if we can have both of these a little bit.
All right, Stefan.
So this is not Meta or Oracle that are basically firing people to invest in HPC resources, right? um, I, I think I would have had the same answer as Stan, but then my thinking is that with the right person in the research facilitator role, we can probably find more money and apply to the grants that I claim that we should be applying at my institution to get more computational resources. That's one thing. Second thing is I don't think we can win the race or we can find enough computational resources no matter how much money that is available because we have a program that is joined with linguistics and they have become obviously some of the heaviest users of resources in campus. And if you tell them what we have, they will tell you that they need 10 times more. And if you tell them that they can go to Access or they can go to Cloud Bank, they will tell you that they need more. So I have the feeling that somebody with better understanding of the ecosystem probably will help them better than simply giving them a pot of money because they seem to exhaust it all the time. So my answer is I would prefer a human in this case because they can probably help me find more computational resources. I have the feeling that we really are not using the ones we have access to, or well, we don't even know we have access to in some cases.
That's a great answer. Okay, Keith.
Boy, this is a difficult question because we're talking about AI servers that there's a huge debate about how much money you can put into it and expect money back. They're talking about putting servers in space that there's free electricity and heat release. So I think in the future that's going to be what we use, and it's going to be telecommunications with the satellites that we're going to need. Um, I unfortunately I don't think I'm qualified to answer what resources you need locally, other than to say you need to have somebody help you decide whether to store your data in Amazon A3, where it's hard to get the data out, easy to put it in, or and how much of it I know I'm going to need. For example, in my case, I have to worry about where am I going to put large data that I need that's active, that's being used for collaboration to generate the tools I need to phenotype a lot of organisms. Um, that's active, but then you got to store it somewhere else. What do you put on tape? I don't know what you do these days. Um, and then what kind of new technology is going to come out with storage? Spinning disks is, I don't know, they got to get rid of those things. You know, we got to do some kind of static drives and increase the storage density. So this is very dependent upon new technology development. And now with all of the circuits becoming light rather than copper based, I don't know what's going to happen, and I don't know how efficient. I hope the efficiency of the servers gets much higher so we don't gobble up all the electricity so everybody's electric bills go up too much. So you use up all our water, you got to stop using up our water. So I don't know. I have a broader point of view on that from societal point of view.
Thank you. And Mike?
Gosh, that's like everyone else. That's a tough question, I think. Um, but one thing Keith said resonates, and the idea that, you know, I don't know what the future of the system here in particular, or in general, university-based systems are going to be. Is it going to be everything moving to cloud-based systems or other? In which case, for me, that would lean towards having a person because that person could help me figure out what's the best outlet to do my computing on. Maybe, like I said, we've got some deal with Google recently where we've got a Google cluster and I just started running some stuff on it. So that's cloud-based. And the latency has been a lot better than I was expecting, actually, but that's a whole nother subject. Um, so if you put a gun to my head and made me pick, if it was near term, like for the next year or two, maybe I'd lean towards hardware. If it was a few years beyond that, I would probably lean towards a person.
Thanks. And Jedediah.
Yeah, very similar to everyone. Difficult question. I would say it kind of depends per university what your research goals are and what hardware you have already. If you don't have a cluster or anything, it's well probably better to get one, and then maybe the faculty can figure it out while you wait for someone to help But so long as you have that baseline, like our cluster here uses quite old hardware, and to me, it's fantastic. Like I love it. So I need that facilitator to kind of help me connect to it and figure out how things are working. And I think it's the facilitator who would navigate kind of into the future, as you're saying, all these new technologies coming out. Having someone working on that full time who kind of sees, hey, we're about to turn around a corner here. Maybe the school should be made aware of this and we should think about updating it. How could we transition into this well? For my school, we don't have someone who does that full time, so that's something that's what I would pick. Someone whose full focus is looking at that, and then also they would help with being able to integrate it a lot more into our grant proposals, into the research of the faculty, and going around and kind of explaining it to them for us. So for my university, certainly I'd pick a human who would have the expertise and be able to kind of help us with that.
Thanks. And Keith, you had your hand up?
Yeah, there's one mechanism that I should mention that we're pursuing a little bit at in Pennsylvania schools. There's something called PenRen, I believe. So it's outside of a university, but it's to create computer resources that could be more towards the scale of what Google might be able to access, but to create those as a paid resource for universities that are small to be able to access whatever portion of supercomputing they might need and not have to pay for it to run all the time because they don't need it all the time unless they've got somebody like astronomers and whoever who will eat whatever you allow them to eat. So, all right.
Yeah, that's a good point. Thank you. All right. This is probably our final question because we're ending in about 13 minutes. But what would you most want a research computing facilitator to know about your work and your needs so that they could be the most helpful to you? And I'll start with Mike.
Um, Probably, well, in the most helpful thing right now is if they know about like efficiency issues with lots of output in massively parallel codes. Um, that's one of the things um, I struggle with, and trying to use the resources that we have more efficiently. Um, in more future stuff, to know, like I was talking about before, what setups and systems might work the most for the particular code that I use. Um, I use code that the model I'm using the most these days is some open source code, and it's written on CP. It's written to run on CPUs. It's not written for GPUs, and I don't have the expertise to rewrite it to be on GPUs. And in ocean or geophysical fluid dynamics, there are a couple climate centers that are working on it, but most smaller modeling groups don't have the people to do that right now. But to help lead me towards something useful along those lines, I think would be the best.
All right. And Stan.
Okay, for the research facilitators, I would appreciate if this person has something what we really don't have, and it is time. Time when we can sit and listen to each other. I can explain, what the problems are, ask for help, but I want something more because I'm not really expert on this. So maybe we are doing this in the method which is not the best or not the most efficient. I want to hear from them, hey, maybe there is the shortcut, maybe we can go pathway B, which I never consider because I'm focusing more on the interpretation of the data. What does it say? Can we actually finish the project with some kind of neural network prototype which is working in order to predict? But this software part and the script could be ancient. So I would appreciate the help from this part as well, not just to do what we are asking, but maybe to have more time. They don't really need to know what we are doing. biologically, but maybe from this computation part, it will be very helpful if they can come up with some kind of assessment and say, hey, this looks okay, or maybe there are some other ways which you guys can use. I will learn from them.
Thank you. That makes a lot of sense. Stefan.
Can I just say exactly what Stan said? I really want them to understand what I'm going through. That's the most important thing. I will add, however, so our institution, when I joined, was a primarily undergraduate institution. It was a research 3, I think that was the classification at that time. It's now R2. We don't have a doctoral program in our School of Computing. So most of our students are undergraduate students or master students. And the researchers from other disciplines, in fact, have even a lower understanding of research computing. So one of the things that is challenging for us is the onboarding of especially early career researchers and student researchers. So what I really need them to do is to really step up and do a better job, because they kind of, I understand the expectations that you need to have some basic skills like Linux programming and stuff like that, but that's really an unrealistic expectation anymore. People have a totally different view of how to use HPCs. And I want them to sit with me to see what I go through my classes before they expect the researchers to have the technical expertise to suddenly access, especially local resources that are not necessarily well documented. I think that's my take on this.
That makes sense. Jedediah.
Oh, can you hear me? I think my screen's frozen.
Yeah, I can hear you. Your camera went a little wonky. There we go.
Okay. Sorry about that. For mine, I would say just kind of understanding the programming languages I'm using. Maybe, like I think I'm good if I'm taking out for loops and doing vectorizing things. I'm like, oh, look at how much time I'm saving. I'm coding so well. But then I try and do things in parallel. I'm like, I need you to do this because I'm very confused how to get this working. So for my research specifically, it's kind of that. But then really echoing what the others are saying, it's kind of working together and them kind of understanding the level I'm at with research computing, which is not very high. My first experience with it was in the University of South Carolina working on my dissertation. And there was a great research facilitator, Mick, and I would send him an email where it's like, I may have destroyed the supercomputer. I'm not sure what's going on. And just the terminology I would use, he would essentially always say it was wrong, which I'm like, that's fine. I just don't know what I'm saying. So I think at one point I said, I'm trying to use this machine. And he's like, it's not a machine, it's a node. So the next time I was like, oh, I'll make sure I'm trying to use this node. And he's like, that's not a node, that's an instance. And I was like, I'm just going to stop trying to explain to him exactly what I'm doing and just kind of, can we work together? I don't have the terminology I need for this. So it's kind of just what I'd like them most to know about my research is kind of the level I'm at with their research computing, and we could kind of work together from my level and maybe bring me closer to their level so we could know what each other are talking about.
Thank you. And Keith, you get to bat cleanup on this one.
So I have maybe a little complicated an answer. I'm going to turn it to the researcher. So I find it in watching scientists over the years really important, critically important for scientists to clarify what the question is they're asking as precisely as possible. And then in the case of computing, then what are the processing data needs? What are the networking needs? What are the storage, needs? If you classified your storage in terms of what's active and what's intermediate and what's you can put away for a long time. Are you sharing data with other people? Those are the things I'm involved with, so I have to answer all those questions. And then if you want, as mentioned earlier, you want people who are willing to listen to your, what is the question you're asking. I feel my responsibility to share what I'm questions I'm asking so that they understand why they're doing this work. They're not just slaves for me. They're going to feel like I want them to feel like they, in a way, belong to the project in some way or understand what they're doing. And people have told me, I don't care whether it's secretaries or people in IT, they appreciate you explaining to them what you're trying to do. You're treating them as people, not just servants. So I think that's really important.
Well, I'm definitely not going to disagree on that point. I think that's an excellent way to think about it. We have about 5 minutes left, so I'm going to give each of you 1 minute to make a wrap-up statement about the importance of research computing facilitation with respect to, um, I'll just say academic research in general. It doesn't have to be specific to your own. So I'll throw it to Mike to start.
Um, I think it's huge. There's people, especially a couple of people have mentioned it already for, say graduate students or postdocs who don't have the experience with it. Having them being able to answer questions are going to help them get on board faster, be able to do research. I mean, say the advisor may have run on that system already and can help them with their particular thing, but then the student wants to do something different. And the advisor has no clue on, say, a different model that's a better tool for doing what they want to do and how you get that to work, and they can founder around and they can go, if it's an open source tool, there may be a bulletin board and they can post a question and pray that somebody answers it for them, but or points them in the right direction. But if there's a resource facilitator that, they may not know the specific tools for that field, but they know what people have used for all sorts of different projects, and they can help point those directions and say, get them to get their system up. And maybe they can work with the person, like the person say, hey, there was this on this bulletin board, they said something about this setting for netcdf, and I don't have a clue. Um, can you please help me? And instead of, them foundering around for like 3 weeks before they go to advisors, like, I can't get this to work at all. If they can get someone who say, yeah, yeah, no, I think I know what that is, and get them up and running that much faster.
Thank you, Mike. Stan, your 1 minute wrap-up.
Um, from my perspective, in current world, the students are way beyond the chat GPT, which they use daily. And if they get involved into the research with me or with our department, I try to show them how to use the artificial intelligence in some kind of more broad biomedical research. And it is many times eye-opener for them, and they figure out, oh my gosh, that's all what I can do. There is really, it's endless possibilities. Once you give them the target or the goal to be their own designers on the project, and they do really wonderful job, because sometimes they come to the office and to my office with their conclusion, and I think that it's just trash. But I start to think and talk to them, and many times I find out that they come up with completely different solution. So that's what I feel, that sometimes we have to listen to them, but encouraging the students in this kind of field of artificial intelligence, supercomputer, showing them how to do, and forcing them to do the project by themselves. It doesn't have to be really the high technology project, but it will help them to understand and be actively involved in research in the future as well.
All right, thank you. Keith.
So I have a three-part answer. One is been pointed out earlier, the importance of relationships. So developing a relationship with some staff member or members, or getting an idea of who they all are and who you should talk to, and starting a communication. Number two is understand at least a little bit about what infrastructure is needed for your research if you're a researcher. Um, and number three, guidance on wise use of AI is going to be the new thing I mean, the effective, intelligent use of AI is really what's needed in the future, to make a difference in society and not ruin it. So we have to be thoughtful about how it's applied. We actually have I'll just close with this, that we have a group that's interested in making sure you're not harming society with your AI. That's an active discussion. I actually introduced that about 10 years ago. Um, Unfortunately, a lot of AI does harm society, and we have to figure out ways to deal with that. That won't be all computer based. It's going to be society based, like legislation based, rules based, you know, laws based. So that's got to be implemented someday by people who understand what AI is and what it can do and what it shouldn't do.
Thank you, Keith. And Stefan.
Yeah, so I'll repeat what I said earlier. I think it's very important to build partnerships. And one thing that I was reminded as we were talking today, it's not just partnerships to help me with research, but even partnerships to interact with the broader IT infrastructure in my campus. So I'll give an example. Our HPC is behind firewalls, and we have significant difficulties even accessing it from my home right now. I have mechanisms, but my students or my outside collaborators don't. So having an advocate in IT to the IT on why specific things need to happen, like I need to have admin rights to my machine to modify and various things. That's very important. And I will also wrap up with answering. I see a question in the chat. Yes, of course. As I said, partnership goes full all the way. And yes, when warranted, of course, our research facilitators are co-authors, as they are also PIs and co-PIs on the proposals. So yes, they get all the full credit and all the full work. Thank you.
All right, thank you, Stefan. And Jedediah, you get to bat cleanup on this one.
All right. So if I were to give a 1 minute pitch on it, I'd say if you've never done research computing, it does feel like quite a steep learning curve at the start, and you do have to put some work in. If you had someone who has the role of research facilitator on your campus, it helps a lot. Building the relationship with them, having them kind of help you through it. But the ability that it gives you at the end is massive, being able to reach a depth of analysis that you couldn't have done otherwise, or even answer questions or use data that was too large to work with otherwise. It does pay off at the end, and I do think it's what we're going to be using in the future. So if you're looking at it going, this is probably too much for me to get involved in, but you're doing research, you're trying to work on something, it's a good time to try and jump into it and see what's going on, especially if you have someone there who can help you with it. And then really going off what Keith said, if you're working with AI, the first step to doing that is to become an expert on the subject you're interested in, because the AI will lie to you. No matter what level of statistics I've asked AI, where I'm like, give me an interesting example for my class, I'm like, that is not how stats works. But if I didn't know that, if you don't know how that's working, you can't use AI. So first you get the discipline, but then it's a really useful tool. It gives you ideas. For me, I'm like, oh, that's a great example. All your math is wrong, but the example's great, and I can write it down to something interesting. But it's that expertise you'd need. Then you can apply kind of the high level computing.
All right, and I want to thank you all for a terrific panel. This has really been wonderful. So let's give our panelists a virtual round of applause. And I'm going to stop the recording in a moment. And oh, that is a lot of applause. That's awesome.